Hello and welcome to Earth Day. We are celebrating 50 years of Earth Day this year, and I am so excited to be presenting Climate Reality's Truth in 10 with you all today. My name is Kristin Quell-Garguilo. I am an adjunct professor as well as an environmental engineer in sustainable systems, and I am so excited to be bringing this to you today. I am a climate reality leader trained in 2018. So without further ado, let's talk a little bit about Truth in 10. So this image is called the Blue Marble. It's a photo of Earth taken from NASA Apollo 17 mission. It was taken as the crew was traveling towards the moon in 1972. And it's a fabulous image because it reminds us that we are all connected and that our actions have an impact on the planet as a whole. So we're going to address three major questions in our slideshow today. The first one is, must we change? Can we change? And will we change? Looking at must we change? The scientific community all around the world has been telling us for a long time that yes, we must change. And now, more than ever, Mother Earth is telling us the same thing. The sky is not a vast and limitless expanse, the way it appears to us as we stand on the ground and look up. In reality, there is just a thin shell of atmosphere surrounding the planet. We are putting 152 million tons of man-made global warming pollution into the atmosphere every single day. Pollution is not the solution to justice or national security. All of this pollution, especially carbon dioxide, is building up and it is trapping heat. Now, greenhouse gases are a natural occurrence that helps keep our planetary body warm. But as we thicken the layer of greenhouse gas material, as sunlight enters into our atmosphere, touches the Earth's surface, and becomes re-radiated as thermal infrareds, those thermal infrared gases, or the thermal infrared material, light, photons, cannot escape our atmosphere and become absorbed by our greenhouse gases. And that creates a trapping cycle, which creates an atmospheric warming. As CO2 concentration increases, the more outgoing infrared radiation is trapped, the warmer the Earth's surface becomes. As we continue to thicken the atmosphere by filling it with heat-trapping pollution, the more heat energy that is trapped, it will warm our planet to unprecedented rates. Causes for these heat-trapping pollutants are vast and many. Here are some of the major sources of greenhouse gases, which include things such as our transportation, which is something that we ourselves can personally cut back on, and also our agriculture. Choices in food is another personal choice that we can make on an individual level. But then there's the bigger things that can be addressed, such as how we produce our electricity and whether we utilize fossil fuels, as well as other industrial uses in our society. Fossil fuels still provide about 80% of the world's energy. Fossil fuel use and emissions have gone up dramatically since World War II, but we are seeing a leveling off as the world adopts more and more clean energy solutions, and we've also seen a recent spike in alternatives to our energy future. As a result to this trapping of greenhouse gases, we've seen a spike to our global temperature rates to a point where 19 out of the 20 hottest years on record have occurred since 2001. And the hottest of all, or the 5 hottest in the last 5 years of time, Heat itself is a problem in many parts of the world and many parts of this country. Heat affects not only people, but animals, crop, and weather. On a global basis, more than 90% of all extreme heat energy trapped by our atmosphere is going into the ocean. This heat makes the ocean-based storms like hurricanes, typhoons, cyclones strong and more destructive. Half of the increase in global heat content has occurred in the last than 20 years. We can see this by huge storms such as Hurricane Florence, which produced record-breaking rainfall, and we've also seen huge small outbreaks of smaller storm events. This is because as we increase the heat temperatures, the more capacity the atmosphere has to hold water. This allows for record-breaking extreme precipitation events. We've seen an increase in an inability to hold back from flooding. I know that this sometimes feels as a contrast because people often wonder how global warming can be blamed for causing both precipitation and flooding events and at the same time more and more drought events. The extreme heat trapped in the rising level of greenhouse gases actually leads to both occurring. As the climate changes, precipitation patterns also change, which leaves some areas with less rainfall, as well as alteration of wind currents and ocean currents, as heat changes the ability for different things to flow to different places. Change in precipitation patterns can lead to drought and water shortages. Southern Brazil, for example, has suffered by devastating drought in 2015 and 16. Higher temperatures also have a direct effect on the incidence and severity of wildfires. Here we see that the number of large wildfires corresponds closely with the years of higher than average spring and summer temperatures. Today, the fire season in the western U.S. is more than 100 days longer than it was in the 1970s. In 2016, this fire in the heart of Canada in the tar sands region destroyed a large part of the cities in Fort McMurray, Alberta, and forced the evacuation of over 100,000 people. The number of climate-related extreme weather events has been going up worldwide according to insurance industries. The last 2 years rank among the top 10 most expensive overall disaster loss, with over $160 billion in loss in 2018 and $140 billion in loss in 2019. Let's talk about some colder places now, shall we? So in this photo, we can see a glacier in southwest Greenland. Was shot in the summer of 1935, and it shows the glacial ice covering in this fjord wall. By contrast, here is a picture of that same glacier in that same location in 2013. This is not even a century later, and due to temperature rise, it no longer exists. NASA has precisely measured the decline of the mass in the ice sheets in both Greenland and Antarctica. All this extra melting is rising sea levels worldwide. This flooding occurs in Miami Beach, Florida on a sunny day with no rain. Now high tides and regular flooding in streets in Miami Beach, as well as several other coastal cities around the world. This is something that's becoming a greater occurrence as sea level rises. The tide lines can now affect flooding events. Looking at this sea level rise, we can also see that asset risk, so risk to expenses in the world over, can be exponential in the near and coming future. Looking at that risk on a more human level, the risk to population as we continue our sea level rise in our future events. But you don't have to take my word for it. We can just look at the U.S. Department of Defense and their 2014 Climate Change Adaptation Roadmap. They cite climate change will likely lead to food and water shortages, pandemic diseases, and then disputes over refugees and natural disasters in regions across the globe. This is something that's going to affect us all, and therefore we should all participate in trying to make changes to help mitigate climate disaster. This can also lead to some major food shortages as we continue to see heat stress and flooding and over rain that can pull crops from soil. As these stresses begin to increase, we will see yields in the most primary food sources such as rice and corn and soybean diminish. And if those food yields diminish, we can also see events of famine, which is quite scary. Infectious disease is also a major thing that we need to think about and look at, as heat stress, air pollution, waterborne diseases are all influences by climate change and not in our favor by any means. Some tropical diseases and their locations and where they've been moving. As we can see, Zika is on the rise. Zika being born of mosquitoes, and the range on the mosquitoes that carry Zika ever growing as they're able to live in new locations as temperature warms. Another thing to think about is biodiversity. We now risk the loss of up to 50% of all land-based species in this century. That's absolutely devastating as diversity of life is dwindling. The cost of carbon dioxide and greenhouse gases and their expansion into our atmosphere is exponential. And the economics just don't add up. When we start to take into effect what fossil fuels are doing to our planet, it becomes a very expensive thing to undertake and continue with. So to the question, must we change? Well, yes, we have to. So the next question is, can we change? Well, we have the solutions at hand. Looking at greenhouse energy processes, one of the projections, in 2000, the world wind capacity will reach about 30 gigawatts by 2010. The reality of how that occurred, by 2019, that goal was exceeded by 22 times that factor. We forget how quickly technology can advance, and it is advancing at such a rapid pace that a lot of the answers are just there and need a little bump and assistance to help make them happen. Global energy capacity has increased exponentially. Global wind could supply the world's electricity consumption 40 times over, as long as we continue to use the technology we have and expand it to places that are wind ready. Solar energy progress. The projection in 2002 said that the solar energy market will grow 1 gigawatt per year by 2010. The reality is that the goal was exceeded 17 times that. In 2002, the projected reality to do that 2010 was more than 17 times. It was an exponential 121 times. Solar can be the answer that provides energy. We just have to look at our energy market differently than we ever have. Solar photovoltaic installations increased exponentially based on gigawatts of cumulative power. The other neat thing is that it can be done on a very personal and small scale, allowing us to increase solar need based on population energy need, which makes it something that can be rapidly introduced and rapidly depleted based on need and moved around based on need. So it is a moving energy market, which is really cool. Another nifty thing about solar is that the cost of crystalline silicone, so the ability to make solar modules, has reduced exponentially as well, and has gone from 79.4 per watt of producible silicone into crystalline solar cell modules down to about 25 cents a watt, which means that production, the ability to produce a solar panel, has become something that's viable and inexpensive. There are other programs out there that allow us to create initial cost reduction in solar and create small affordable systems, and this allows the growth of solar in developing nations as well as already developed nations. This is why somebody like yourself or your neighbor can have solar on their roof. And this is pay-as-you-go solar products and industry, which has been popping up and growing. The amazing thing about solar energy potential is that there is enough solar energy that reaches the earth every hour to fill all the world's energy needs for a full year. So the better we can advance the technology, the more we can make it readily available, the more power we can produce. We have a clean, green solution to our energy needs that we can make equitable and available to all people. Which brings me to the global cumulative storage capacity. Historically, the biggest downfall of solar is the inability to store that power so that we can use it when we need it. Most of our electric needs happen in the evening when it becomes dark and the lights go off. Therefore, we have to be able to store this energy. And this is a growing market as well that we've seen growing in its ability to store electricity capacities. And as you can see here, the historical records are showing an ever-increasing growth in gigawatt capacity of storable. And the projected future has very high hopes. And so soon enough, we're hoping to be able to store exactly what one would need and then some for everybody to have enough to go round. Looking at some other small changes to marketplace, we have LED lights, which is a great example of technology being adapted. And back in 2010, it was only about 1% of the market share of light bulbs that were out there, or lighting systems that were out there. And now you can see that it's grown so that it's becoming the answer. And it will take over the full market share in the next 5 years. We will see only about 5% of lights being some type of incandescent bulb. Another major piece of the answer to the energy puzzle is looking at vehicle emissions. Vehicle emissions are non-point source pollution, something that's being spread around and not necessarily tracked, so I can't point to it the same way that I can point to a energy provider, something like a coal burning electrical plant. I can point to that and say that needs scrubbers, that needs some way to reduce pollution. Vehicles, on the other hand, go all over the place with the tailpipe and exhaust pollution happening and creating carbon dioxide and carbon monoxide into the atmosphere. On the other hand, auto manufacturers see the future as being electric vehicles. And here's just a list of some of the electric models in production currently. So yes, we can change. We have the technology. It's there. We just need to embrace it. Which brings me to the last part. Will we change? And this is kind of the big nebulous question, right? It's up to us. Will we change? And yes, it does require collective action. So the 2015 Paris Agreements, every nation in the world agreed to work together to achieve a net zero greenhouse gas emission by the mid-century. We do know currently that the U.S. cannot legally withdraw from this agreed upon accord. And therefore, we are going to be making some major steps in moving forward. Some things that give me deep hope. This was the People's Climate March in Washington, D.C. in 2017. Look at those numbers. People care. They want a world that has climate equity and climate justice. They want to see a clean, green planet, something that's healthy and safe for everyone. So the question is, would you join those who are using their voices, their votes, and their choices to fight a climate crisis? Because you can use your voice, your vote, and your choice to speak truth to power. Like your world depends on it. Because your world does depend on it. Thank you, everybody. Happy Earth Day.